So for our next talk, we'll be having two engineers from Twitter going to talk about predicting resource usage of future queries based on 10 million PrestoDB queries. Did I move my slide accidentally? Hang on. Okay. And Shunsu is a software engineer in the interactive query team at Twitter. He's been working on Presto and Zeppelin services, and he loves hiking, playing badminton, and cooking. Okay, that's one of my hobbies as well, just the cooking part. And Bainan is also an engineer with Twitter interactive query team. He's helped scale Presto to fit Twitter's data platform. And prior to the IQ team, he worked for the core services team at Twitter. So I will let you take on from here and see if you can wrap it up in about 20-25 minutes. So we'll have 7, 8, 10 minutes in the end for people to ask questions to both of you.
Sure, thanks. So, okay, hi, good morning, everyone. This is Chunshu Tang. Today, my colleague Beinan and I will talk about how to predict the resource usages of future Presto queries based on around 10 million historical Presto queries. So it's a story about how to use machine learning techniques to help us to improve the productivity of Presto at Twitter. So I don't know what's your folks' opinion on this topic. At first, the one Beinan and I took this idea to some of our colleagues at Twitter. They feel kind of weird or confused about it. How machine learning and Presto could used combined together to improve the productivity? Can it really work? And the answer here is yes. Today, Beinan and I would like to share some stories about how to use that kind of tactics to help us to solve problems in data systems. And also there's another thing that I want to mention here is that machine learning is quite broad and complicated concept. And sometimes we may even need a series of classes to learn about it. But here today, we don't expect you folks have any background of machine learning, but what we would like to focus on is how to come up with kind of methodology, kind of ideas, how to come up with these approaches to use machine learning to help us to solve the problems at data platform. So our story, there are 3 stories that we would like to share today. The first story is about the Presto story at Twitter, and my colleague Beinan would like to talk more about it. And then I'll talk about the query predictor story on Twitter, and then we'll do some wrap up about what we have learned. So let's invite Beinan to talk about the story at Twitter.
Thank you, Chunshu. I'm Beinan from Twitter. Okay, yeah. Next page, Chunshu. Yeah, we started using Presto, I think from 5 or 6 years ago. We start with a very small Presto cluster at first, but then after we onboarding more and more users, especially for some huge data size, we are seeing some scalability issues at Twitter because we need more workers. But when we scale up, when we have more than 500, 800, 1,000 workers, we are seeing the coordinator become more vulnerable. Yeah, because for each Presto cluster, we only have one Presto coordinator, but we can have multiple workers. Yeah, but the coordinators will become, we are suffering some GC issues, CPU throttlings when we have more workers. And also, because we have a huge user set in Twitter, we have a longer waiting queue. And also we have a lot of guys, they love the UI. They check their query status in the Presto UI all the time. It makes the coordinator, the status coordinator even worse. And also, we have a lot of scheduled jobs like ETL jobs in Twitter. We are seeing some availability issues because the coordinator is a single point failure there. And when we redeploy the Presto, the entire Presto cluster will down, right? We cannot handle any query anymore. Okay, next page. Yeah, so I think it's last year, another team member in my team, Hao and I, we developed a router. It's just something like a load balancer, just in front of all the Presto clusters. Then we can have more clusters work together. For each subcluster, sub-Presto cluster, they just have 200 or 400 workers there. So we are seeing much less issues in the coordinators. So in total, we can have more than 1,000 workers. Actually, we are running 2,000 to 3,000 workers for the Twitter. And because we also implement a UI in the router, so the users can just check the UI in the router. And the major difference of this Presto router from the Presto proxy is we are using a redirect. It's quite lightweight for each router instance. That means we won't hold any data transferring during the query running. For each new query, the router just redirect the query to the subclusters. So during the running, the client will fetch result from the subcluster directly. So we can easily to scale up and scale down the each clusters and also the Presto routers. We can start rolling, which means we have 0 downtime during the deployment. Okay, next page. Yeah, this one. Yeah. At first, we have some basic scheduling method for this router, just like some other normal backend load balancing. We use round robin. Also, we try some random dispatch. Also, because we have some special use case for Tableau users and for the schedule users. So we also have some fixed routing. We just route the Tableau user to some certain Presto Tableau cluster. But based on this kind of balancing approach, we are seeing the resource usage is not very perfect. We are seeing some starving cluster. We are seeing some cluster too busy. All the queries are stuck there just because it's too busy. And it's somehow waste of the resource. And for some busy clusters, we are seeing the longer execution time, especially some waiting time, because the waiting queue is full, it's too long. Okay, next page. Yeah, so we are just thinking about what's the difference between the Presto router and some other load balancing. It's just because the resource usage of each query are quite different. For some query, it just take 100 milliseconds, but for some huge query, it will take you maybe more than 4 hours or 8 hours or a whole day to run. So if we dispatch the huge query to one subcluster, it will make that cluster crazy. So we're just thinking, maybe we can collect some data, some logs, and then do some analysis. We call the query predictor, which Chunxu will provide more details later. And then we can have more knowledge about each query. We can do the query scheduler better. That's the basic idea of this Presto router, predictor, and scheduler. Next page. Okay, yeah, let's leave the remaining of this presentation to Chunxu, which is the most juicy part of this presentation, the query predictor.
Okay, thanks, Peinan, for your sharing. So let's go further on the journey to the query predictor. So here I would like to share more about the story of query predictor of Twitter, like how we used a machine learning techniques to help us to predict the cost of a SQL query. So as what Peinan has shared, so we would like to have a query predictor, which could be used to predict the CPU and memory resources of each future SQL query. The query predictor could be used by various platforms. For example, it could be used by a web application which we have created. It could be used by business intelligence tools like Looker and Tableau. It can also be used by notebooks such as Zeppelin and Jupyter to provide some estimated execution statistics to end users, to customers. At the same time, this query predictor is also used by the router, Presto router side, to schedule the queries intelligently. So here is a high-level design of the query predictor. So on the very left, we have lots of historical queries, and these queries will be fed to some models for training. So two models will be generated after the training. One is the CPU model, which is used to predict the CPU time of a SQL query. And the other is a memory model, which is used to predict the peak memory bytes of a query in the future. And the two models are wrapped into a service called Query Predictor Service. And the service provides some APIs to the external world and could be called by some other services at Twitter. So here is the web application we have created at Twitter. So here is a text area, so the user can just fill in a query here. So here I put a very simple query from TPCH benchmark, and then the user can just click the predict button here to get the predicted CPU time. For example, here it is 30 seconds to 1 hour, and also the predicted peak memory bytes here for the specific SQL query. Okay, so let's talk now about the machine learning pipeline here. Before we jump into the specific implementation of the query predictor, I would like to say more about the general machine learning pipeline, because for this tech talk today, what we would like to focus on is not just a specific implementation of query predictor, but what we can get, what we can benefit from the main concepts of the main ideas of the query predictor behind. That is, maybe sometimes we can apply some kind of machine learning techniques to help us to solve problems at data systems, not just the Presto, or maybe not just the query predictor. So for a machine learning pipeline, the very first thing we need to think about is to define the problem. What is the problem we would like to solve? And what is the input and output of that problem? And then we can prepare some data from data ingestion. And then we could do some model training to get some models, and we serve these models. And finally, when the models have been online, we also need to do some monitoring to continuously monitor the performance of these models. Okay, so the very first thing and the most important part in my mind is about the problem definition. So here our task is to predict the CPU time and the peak memory bytes of a SQL query. So the very first question is that, what should we output? Like, do we need to output the specific CPU time, like 1.0123 seconds or so? In our experiments, what we have found is that for query scheduling or for customers to get some quick sense of their queries, we don't need to have a very specific, very accurate estimate of the CPU time. What we may need to do, for example, is to differentiate whether this is a really long query, as Beinan has mentioned. It may cost like longer than 1 hour to execute, or it may be a very short query. It just cost, for example, 30 seconds to complete, right? So based on that kind of idea, we come up with this problem definition that we don't need to predict the specific accurate time of CPU time or memory bytes of a specific query, but we would like to put this metrics into different categories, into different buckets. Take the CPU time as an example. We have 4 buckets: shorter than 30 seconds, 30 seconds to 1 hour, 1 hour to 5 hours, and longer than 5 hours. And almost the same for the memory byte side. So in that case, our model will be like converted from a regression model to a classification problem. Okay, so the next question is that, what data do we have? At least we need some data for the training, right? Luckily, for Presto side, we have a huge amount of Presto query logs. We have around 10 million Presto query logs here, and that's what we have built, the whole query predictor pipeline for our project. So we have the raw Presto logs, and these logs will be converted into categories, into different categories. And the step here is called data discretization. And then we'll do some data cleaning. And then if you folks have some background of machine learning, usually for classification problems, we need to split the data set into a training one and a testing one. And we will train the model on the training data set and then evaluate these models on the testing data set. So we split it into 80% training data set and 20% testing data set. And then we'll apply vectorization, TF-IDF, which is a very common concept in natural language processing on these SQL statements. And then we use XGBoost, which is a gradient boosting decision tree model to train these models. And then on the testing data set, we do the data transformation based on the vectorizer we have trained, and we'll also evaluate these models. Okay, so here are some results we have obtained in our training. So for the CPU time model, the accuracy is as high as more than 94%. And for the peak memory bytes model, the accuracy is as high as around 92%. But here a question may be raised. Is accuracy always be a good metric to evaluate the performance of a model? The answer may not be true. And here what I want to share with you guys is about some other metrics for model evaluation, such as precision and recall. Take the recall as an example. The recall is used to evaluate how many relevant items have been selected correctly. So take the CPU time model as an example. Here we have a row which about the queries longer than 5 hours. The recall here is 90%, which means of 90% of the large queries have been predicted correctly. So suppose that we have a quite stupid, very simple query predictor, which always predicts all the queries CPU time is smaller than 30 seconds. And then we have 100 queries here, 99 queries, their CPU time is smaller than 30 seconds, and only once CPU time is longer than 5 hours. The accuracy here could be as high as 99%, but the recall of the queries longer than 5 hours will be 0 because none of the queries in this category can be predicted correctly. So that's something that we need to be especially concentrate or need to be keeping in our minds that when we would like to evaluate some models, we also need to take care of other features, other metrics to help us to get a broader concept, a broader understanding of these models we have trained. So the last thing we want to share is about what we have learned. I think that's also a very important part of this presentation today. And here are some key takeaways that we would like to share with the whole Presto community. The first thing is that machine learning can be useful, can be really helpful on our side. Some basic models, like what we have trained, can give quite good results. And the second takeaway is logs are a kind of reliable starting point for machine learning. And we also need to know that machine learning requires lots of models for training. And then the last thing is that be careful. Machine learning is not a panacea. It's not a silver bullet that can be used to solve all our pain points. No, it's not. Models should be evaluated on various metrics, not just accuracy. Okay, so that's all about our tech talk Beinan and I have today, and we are here ready to help. If you have any questions, you can also ping us in the Presto Slack channel. Thanks so much for your attendance.
Great, thank you so much, Junsu and Beinan, a great talk. We do have a question that I'll read out for you so that we can take it live. Question from Ash, do the query logs fed into the model include the explain plans or just the query text? Because two similar looking queries might have different plans that will affect the prediction. Junsu or Beinan?
Yeah, I think I can answer this question. The question is mainly about some techniques in the model training part. So in our case, on the Twitter side, in our case, in the query log, what we have is about a SQL statement and then we'll have the CPU time, the accurate CPU time of this specific SQL query, and the peak memory bytes of this SQL statement. And then we feed this kind of thing to the models for the training. So the next question is about whether two similar looking queries might have different plans that may have the very different results, right? So that's a kind of amazing part for the machine learning side. In our experiment for now, that what we have learned is that similar queries at Twitter usually have kind of similar results, and the machine learning part, the machine learning algorithms can predict them quite accurately. And we also know that there is a small amount of queries, similar queries, really generate some different results. And interestingly, the machine learning algorithms also predict them quite accurately. That's also one reason why we choose a decision tree model here, because if you have some background of machine learning, you know that for decision tree, usually it's quite easy for us to visualize the tree structure and find some rules that how the algorithm help us to classify the problems. So that's also something that we can learn from the machine learning side to help our engineers to know better about our systems. Yeah. Yes.
Great, thanks for answering that. We'll just take one more question and then wrap up. How do you take care of the same query on different data sets or tables?
I think Beinan maybe know more about it. In my opinion, actually at Twitter side, we don't have same queries on different data sets because, like, for example, we have a tweets data set, and the tweets data set only one data set. Suppose there's another data set that then there won't be like tweets. We need to write another different query for that. Beinan, am I correct? Would you like to add some more materials on that?
That's true. In Twitter, there is something different. We have something called ViewFS, and based on that, we only have one meta store. So that means each data set will be there just like a unique data set. We won't copy the data set, everywhere to other cluster. We do, but if we're doing something like that, that means we create a totally new data set. So the query there won't be exactly the same. At least the table name should be different. And also the data range must be different because we just copy maybe a small range from some data set to another or something like that. Yeah.
Great, thank you so much. The Twitter team as well as the JAM team, on behalf of the Outreach Committee, really a big thank you to all our speakers today. Two great sessions. Folks, if you have more questions, you can type them in right now, and we have access to this so we can answer them after the session. In addition, we'd like to say that we have a new channel for feedback from you. So we'd like to hear from you. Are there other sessions, other topics that you would like to hear from in our virtual meetups? This is our third virtual session this month. We already have a great set of sessions planned for next month, but would be great to hear from you at feedback@list.prestodb.io. If you would like to present, or if you have suggestions, let us know. In addition, right after this, we'll send out a survey to the meetup group to hear your feedback as well. And Amit and I and the outreach team are always looking at ways to engage better with everyone in the community, and looking forward to hearing from you. The recording from today will be available on our new YouTube channel that Amit announced earlier in the session. And with that, we'd like to wrap up today's session. Thank you so much for joining, everyone. And thanks again to the Twitter team as well as the JAM team for presenting. Take care. Cheers. Bye-bye.
Thank you. Thank you, everyone.
Thank you.
Thank you all. Bye-bye.